to kick off our afternoon session. Please go ahead and take your seat. You prefer to have the microphone on the podium or not? I'm also the So for those of you who have not yet noticed, there is a theme throughout today of community and communications. And we're continuing with that theme this afternoon as we move into our second keynote of the day. It is with great pleasure that I introduce you all to Rebecca Breismoore. She is Water Resources Engineer and Project Manager for the Colorado River District. She has a civil engineering degree from Iowa State University and a master's in environmental management from Western Colorado University. She's worked as an AmeriCorps environmental manager, a Peace Corps coordinator on environmental stewardship and science, a hydraulic engineer for the U.S. Army Corps of Engineers, and other roles. And throughout all of this, she's driven by a lifelong love for water and soil that began very young when she was growing up sowing seeds and digging in sand piles along the rich soils of the Mississippi River in Iowa. And today she's going to be talking to us about the Colorado River District's Community Funding Partnership Grant Program, which has supported multiple soil moisture monitoring projects here in Colorado. And the efforts around this work are related to improving water management and decision-making capabilities and helping to reduce uncertainty in snowpack, help create forecasts that are better adapted to changing conditions, and figuring out how they can support work that will help create tools that are needed by stakeholders and decision makers. Please join me in welcoming Rebecca.
Thanks, Elise. That was a really great introduction, and I feel like really encompassed all parts of my talk. So I'm pretty much done here, and I'm just kidding. Really appreciate that introduction. As Elise said, my name is Rebecca Breismoore, and I'm a Water Resources Engineer and Project Manager for the Colorado River District. And today I'm going to give a little bit of background on who the Colorado River District is, what we do, and why we see soil moisture as an important tool in closing the gap that we have between our snowpack and our runoff forecast. And I'm also going to talk about a couple of projects that we have funded through, as Elise mentioned, our Community Funding Partnership Grant Program that are putting up soil moisture monitoring stations around basins to provide more data to water managers and decision makers so that they can better utilize and make better informed decisions with really limited water supplies in some cases. So to kick it off, since we have people from all over the country, I just want to give a little bit of a background, which is fairly basic geography of the state of Colorado. This is a map of Colorado broken out by counties. And we know that Colorado is pretty unique in terms of geography in that we are right on the continental divide. And the state's divided with this very approximate red line of the continental divide. And water, of course, flows downhill. So water that falls on the east side of that continental divide or to the right of that red line ends up in the Mississippi River watershed and eventually goes to the Mississippi. And water that falls on the west side of the continental divide, or to the left of that red line, ends up in the Colorado River Basin watershed. But water isn't that simple in Colorado. It doesn't always go downhill. What we know is that sometimes water goes across mountains. And that's because in the state of Colorado, 90% of the population lives east of the continental divide, but only 20% of the state's precipitation falls east of the continental divide. And so when Colorado was being developed in the early 1900s, there were a lot of needs for water use on both sides of the divide, but there was a really big pressure on the east side because there was more people, there was more agriculture. And so water users started moving water from the west slope of Colorado to the east slope. And western slope water users living in that blue shaded area and all the users on the other side of that red line thought, wow, we really need to have someone to represent us and to unify us because we don't have the population, but it's still really important for us to be able to use and develop and conserve our water. And so that's why my organization was formed. The Colorado River District was formed in 1937 to unify the voices of West Slope water and to be a representative, unifying voice for those water users so that they have someone to represent them on a state level. And so today we still represent those water users. We oversee a district of 15 counties on West Slope, Colorado, which is a really large portion of the Colorado River Basin headwaters and a large portion of the West Slope. And our mission is kind of two parts. The first part I just mentioned is really to serve as the watchdog of West Slope water and to represent West Slope water rights. That's kind of our regional focus. And the second part of our mission is a more broad interstate focus. And that part of our mission is to safeguard for Colorado all waters of the Colorado River to which the state is entitled. It's a pretty large focus, and it really deals with all of those things that we see in the news about the Colorado River Compact and the renegotiations on how the river is operated and administered. And we want to play a part in that to protect not just our water users, but the water users across the state. And when we're looking at the entire Colorado River watershed, it's encompassing 7 states, including 2 countries, Mexico and the United States. And when we look at this map, we can see that there are these gray areas. And those gray areas are areas that are physically outside of the basin of the Colorado River watershed, but that receive water from that river. And we can also see that blue basin right there, that is the Colorado River District boundaries, the area we represent. And this red text right here, Lee Ferry. Lee Ferry is a point of measurement on the Colorado River. It's a pretty important point of measurement for various reasons that we're not going to get into today. But one of the things that's really important to us is that 65% of the natural flows at that measurement point at Lee Ferry originate within our district boundaries. So we're a small area. We don't have a large population, but we play a critical role in the management, or not in the management, but in everything that happens within this river, because over half of the flows of the Colorado River, of which 40 million people depend on, originate as snowpack or precipitation within our district. Now we have a pretty small staff to oversee this pretty large mission. We have 25 people on our staff based out of Glenwood Springs, Colorado, right on the main stem of the Colorado and the confluence of Roaring Fork River. And we have various staff. We have legal staff that represents our water users in water court. We have a technical staff, which includes me. We provide technical assistance and work as facilitators for stakeholder organizations who are doing projects in our district and work on a lot of technical data to make sure that decision makers have the right data to make decisions. We have a policy work experts who work at the state legislature and the federal legislators to make sure that West Slope interests are represented and they have data they need. We have our education and outreach team, which works out in our basin to put on events and make sure that our taxpayers who fund us understand the work that we're doing to represent them. We have our community funding partnership program, which is, as Elise mentioned, a grant program that was stood up in 2020 through a ballot initiative to essentially give back taxpayer money to that we receive to water projects that are happening within our district. And this grant program has been going on for about 4 or 5 years, and it's only a $4 million bucket annually. We've been able to give $28 million to 135 projects since its inception. But the key success of this project is not just the money that we've been able to put in, but the $96 million that we've been able to leverage in state and federal and other grants by coming to the table with West Slope funding. And then, of course, we have our finance and administrative team that keeps the lights on, keeps our budget going, keeps gas in our cars to support the work that we're doing. And I'm going to talk about 2 soil moisture projects later in this presentation, and they both received funding from that community funding partnership program. So Colorado water is, of course, very complicated, as anyone who lives in Colorado knows. And this is a map showing all of the water rights within our district boundaries. Every single one of those red points is a water right. In Colorado, to use water, you have to have a legal right to use water, whether it's a municipal, industrial, or agricultural use. And every single one of those water rights users relies on forecasts to make decisions on how they're going to use their water every year. We know in Colorado that there's two really main components for how water operates. The first is that most of our water comes from snowpack in the winter, which means that our hydrograph is really volatile. We have really low base flows in the winter. In the springtime, that ramps up as we have all the snow melt and we have a peak hydrograph. And then it tapers off through the rest of the summer and fall and goes back to those low base flows. So we don't always have water when we need it. And West Slope residents don't live downstream of big reservoirs like Lake Powell and Lake Mead. So we have the water that we have when it's available, and when it's gone, it's gone. So managing our water resources is really important. And the other component is that annually, year to year, our water supply can be also very volatile. We can range from really low dry years to really wet years, depending on our snowpack, depending on temperature, depending on a lot of other circumstances that happen within our basin. And so we have to learn sometimes to live with less. So we rely on these water supply forecasts that come out throughout the winter to give us an idea of what the water year is going to look like. I can't tell you what next year is going to look like. I have no idea what 2026 is going to look like in terms of water supply forecasting. But based on the water supply forecasting for 2025, we have a fairly good idea of what we're looking at this year, and it's probably going to be a dry one. And one of the agencies that does this water supply forecasting is called the Colorado Basin River Forecast Center. And this is a really a government agency based out of NOAA that does forecasting for the entire upper Colorado River watershed. And they use conceptually based models with some observed data and also historical forcings to essentially look at analog years and come up with a forecast for the year for different points within the basin and to estimate that water supply. And every month throughout the winter, they come out with a new forecast. And they do use soil moisture as a modeled component of this forecasting. And in November of every year, they come out with this map that they put out publicly that gives everyone an idea of what we're looking at for modeled soil moisture within the upper Colorado watershed. This is just a screenshot of Colorado from last year. And we were looking not great in a lot of portions. The Gunnison River was looking a lot better. That upper Colorado Fraser River system, not awesome. But they do use this in their forecasts, this modeled soil moisture. But what we're finding is that we have increased uncertainty in our water supply because of climate change. And one example is to look at temperature. This is a map showing the average June temperature for Routt County for the past 130 years. If you've ever been skiing in Steamboat Springs or been to Steamboat Springs for mountain biking or any kind of other activity, that's where this is. This is Routt County. And over the past 130 years, we've seen a 3-degree average temperature increase in Routt County, which is really significant, as you all know. And we're seeing even greater temperature increases in the fall, when soil moisture is obviously really important going into winter. And what we know is that with every 1 degree rise in temperature, stream flow diminishes by 3 to 5%. So it's not a linear increase, it's an exponential increase, and some studies say it's even more than this. So if we're looking at a 3-degree temperature increase in June, that means we're looking at a potential stream flow impact of 8 to 14%. And we're seeing all this uncertainty play into our water forecasting. What the historical ways that we've used to forecast water supply are just not really giving us the full picture anymore. We're seeing this mismatch sometimes between the water supply that we get and the water supply that we forecasted for. And one example that was really stark was in the winter of 2020 to 2021. In 2020 to 2021, they had pretty much average snowpack for the whole upper Colorado watershed. In all of our region, we were looking at average snowpack. And so we expected an average runoff season. But when that runoff happened, it was only 60% of average, which was a big shock. And it triggered the question, what happened to the water? And one of the hypotheses was that soil moisture played a role, because 2020 was a severe drought year. And soil moisture measurements going into the winter of 2020, 2021 were some of the lowest on record. And so there was that question, how much did soil play a role in sucking up all that water and minimizing our stream flow runoff? This is an example of this year, what we're looking at for our water supply forecast. This is a plot from the Colorado River Basin Forecast Center, and this is a inflow forecast for Lake Powell, which is obviously really important to the upper basin states of the Colorado River. And you can see over time, this is the bottom axis, the x-axis is time, the y-axis is volume, and these pink bars are their probability forecasts of a range from the lower range to the upper range to the most probable in the middle. And you can see over time that with less uncertainty, as we know what our snowpack looks like, that bar narrows and we get more and more certain of what that water supply is going to be. But what's really interesting for this year is the drop between April to May forecast. We saw a 20% decrease in the expected forecast from April 1 to May 1. That equates to 800,000 acre feet of water, which is huge. So our forecasts aren't really showing us the full picture. Uh-oh. Did I turn it off? Hello? All good. It was like, your presentation is too boring. Stop already.
That was on the edge of our seats. We just heard about the
800,000, what? Yeah. So we're looking at these water supply forecasts and essentially thinking, is this on? Yes, okay. And essentially saying, we're not seeing the full picture. There's something missing. We need to look at other data to figure out where the gap is between our snowpack and between our water supply. Is that one? All good. All good. So I'm an engineer. So I like to think about this as an algebra equation, and I'm sorry in advance. But historically, we've looked at water supply is equal to snow water equivalent with some historical data. Let's look at past years and try to equate the current year to past years to get an idea of how much water we're going to have with some observed data. But that's not giving us the full picture. So my thought is, what other variables are missing in our algebra equation that we have to solve for? Maybe we have to solve for X, maybe Y, and who knows what else. But there's other variables that are important for estimating water supply that we need to take into account. And soil moisture is probably one of those, as well as other factors. We probably need to take into account sublimation, dust on snow, climate change, temperature. All of these are different variables that impact our water supply, and it's different in every basin. So this is a very complex algebra equation, but soil moisture is a huge component. So I want to talk about a couple different examples that we're looking at in our region. This is the Yampa River watershed, and the Yampa River watershed is that Drought County, Steamboat Springs area that I talked about. It's a really diverse basin, starts in the flat tops of the Drought National Forest, the White River National Forest, and it meanders down through agricultural lands, through Steamboat Springs, which is a recreation-based tourism economy with skiing. It goes into more ag lands with riparian forests of cottonwood, through sagebrush, and eventually through Yampa River Canyon to Dinosaur National Monument, which I definitely recommend if you ever have a chance. It's awesome. But this river, stakeholders like to say, is wild, because it doesn't have a lot of reservoirs. It has less reservoirs than most rivers in Colorado. And so there's not a whole lot of options to really control the water or to mitigate a dry year. If you have a dry year, you're kind of just dealing with it as it comes. And in the summer, or in the 2020 to 2021 winter that I mentioned, this basin was hit particularly hard with that diminished stream peaked, and that full water supply for stream flow was about 30% of average. So they had about a 30% decrease from, you know, what they were looking at for their average snow or their snowpack to the stream flow. And so there was a group that came to, oh, wrong slide, and community impacts. So there's a lot of community impacts when you're looking at these low flows in dry years. Recently, this article just came out a couple of weeks ago that talks about a fishing closure downstream of Stagecoach Reservoir on the Yampa River due to low water. And this other picture is an attention water users asking people to voluntarily stay out of the river in Steamboat Springs for recreation because of high temperatures and not wanting to stress that river further. And Steamboat Springs is really connected to its water. They're really connected to the Yampa River, as well as being a recreation-based economy that really relies on skiing and fishing and all kinds of other activities for their economy. And so these just don't have an emotional impact, they also have an economic impact to this community. And one of the ways that they do try to mitigate is using their very small storage buckets to release water later in the year when they're seeing those low flows. This is a release that they did in 2023 when they actually weren't expecting to have to do a release because it was a really high water year, but the stream flow just really plummeted at the end of the year. And so they ended up doing a release out of the Stagecoach Reservoir to try to boost that stream flow and help out the fish and the ecosystem. But it's really critical to understand how much water supply is available to be able to make these decisions. It's like understanding your bank account. You have to understand what your budget is so that you can decide how you're going to spend your money in different ways to most effectively use it. It's the same way with water. Water managers and ranchers and recreationists are all trying to understand how much water is going to be available so that they can make decisions such as how many guides are they going to hire for their rafting trip, or how much water are they going to let out of a reservoir now or save for later. Ranchers are making decisions on how many cattle they can afford to keep or how many acres they're going to irrigate this year, all based on these water supply forecasts. And so this project that got started in the Yampa River Basin, my organization funded $140,000 in January of 2023 to help expand this network within the Yampa Basin, and it's called the Y Basin, and it's coming together with a group of partners, including the Yampa Valley Sustainability Council, the Center for Western Weather and Water Extremes, Colorado Mountain College, and the Upper Yampa Water Conservancy District, to basically put in soil moisture measurement stations to better understand that relationship between snowpack and runoff. And their goal is to really establish this long-term soil moisture monitoring program so that they can provide data and insight for how that reduction in soil moisture really plays into that stream flow forecast, and also to have a continuous record that they can use now and in the future to better inform that relationship and support operational model and forecast improvements. And they were interested in a few other goals as well. This is an area that has a lot of interest in wildfire mitigation. There's a lot of infrastructure in the wilderness-urban interface. They're also really interested in plant survivability and how reservoir operators can manage their reservoirs. And some other different goals that they were looking at, but mainly that relationship between snowpack and stream flow runoff. And so they have currently 5 stations within their basin that they've set up to look at soil moisture. The first station was installed in fall of 2022. So this is a really new network, and they're still looking at how they're going to use that data to inform and what patterns they're seeing in that data. But they essentially have these stations that measure soil temp and moisture at 6 different depths, and then also include other measurements like air temperature, relative humidity, wind speed, etc. And you can see that they were really intentional where they placed their soil moisture measurements. The green stations on that map are existing snow-tell sites, which measure the snow water equivalent from the snow depth. And those blue sites are where they put the soil moisture data measurements. And one thing that we see with snowpack in Colorado is that it's really variable. And it's not just variable from basin to basin, but it's really variable in terms of elevation. It's very variable within just one side of a hill versus another side of a hill. And so putting those soil moisture measurements in areas other than snowpack was one method they were using to try to fill the data gap that we're seeing in all of our forecasts. And yeah, and so this one's new. So they're still working on finding patterns, still working on finding that relationship, the local relationship between snowpack and runoff. But it's better late than never to start a continuous record of data. And we see this as one of those long-term durable solutions to being able to answer some of the questions that we have in terms of addressing uncertainty in our water supply. The other example I want to talk about is the Roaring Fork River Watershed Project network, and that's called IRON. If you have technical questions about this, we should definitely ask Elise, because she is the one who did a lot of work on this, and I'm not the technical expert. But to give you an overview of the Roaring Fork watershed, this is a direct tributary to the Colorado River. If you've ever been to Aspen, Colorado, it originates up in Independence Pass near Aspen, really beautiful area, known for the Maroon Belt Mountains, very picturesque, and starting at 12,000 feet elevation if you want a really tough hike. And then it flows all the way down through this corridor down to its direct confluence with the Colorado River at Two Rivers Park, with the Roaring Fork River and the Colorado River confluence. And what we found, or what this organization has found, is some interesting pieces about the water balance. And this is local regional data to the Roaring Fork watershed, but I think this is really interesting to highlight for not just this watershed, but something that we should consider for all Western watersheds. And this is a graph showing the water budget. And we can see in this water budget, this blue column on the left is the precipitation, and that varies annually quite significantly. Over this approximately 12-year span, you can see that there's years where it's pretty low at about 1.5 million acre feet, and then there's years where it's at 2.5 million acre feet. It varies significantly. But what doesn't vary significantly is the amount of evapotranspiration. That's pretty constant. It's almost the same every single year, which means that in those dry years, you're losing up to 80% of your water to evapotranspiration. That's huge. And what we also know is that increasing temperatures lead to increased evapotranspiration. We lose more water with higher temperatures. So how does that relate to soil moisture? Well, more evapotranspiration, more water loss with higher temperatures in our soil. So understanding these relationships is really important to being able to quantify the amount of water that we have and the amount of water that we're going to lose. And so this Roaring Fork Observation Network, or IRON, was stood up by the Aspen Global Change Institute. And they wrote this really good guidebook on soil moisture, which I truly recommend. It's a great read. Thanks, Elise. It's awesome. You should read it. But this organization had a really similar goal to answering some of the questions with soil moisture as the Yampa Basin group. They were looking to help land managers, local residents, and scientific research understand that relationship between snowpack, soil moisture, and stream flow in Western Colorado, but also beyond. And this observation network has actually been in place for over 10 years, since 2012, which I understand from hearing some of the other presentations that that's not a really long time for a lot of soil moisture networks, but it's actually fairly unique for the Mountain West to have a soil moisture network that's been in place for this long. That's not just an agricultural soil moisture measurement. So there's 10 soil moisture stations total. And as I mentioned, this goes from really high elevation at over 12,000 feet down to about 6,000 feet elevation. So they're capturing a really wide ecological and elevation gradient. And they measure soil temperature at several different depths, they measure soil moisture at 3 depths and soil temperature at 1 depth. And then they're also measuring some of those other parameters such as relative humidity and rain and snow depth. And this has been in place for about 10 years. They're still looking at some of those patterns, some of those relationships, and how they can use this to inform decisions. I'll mention that along this stem of the Roaring Fork, there really isn't any reservoirs either. So again, we're working with what's available, what Mother Nature provides us is the water that we have at the time that we have it. So just kind of some concluding thoughts. You know, accurate water supply forecasting is really vital for everyone on the Western slope because we have a limited water supply. It's scarce. And when we have dry years, people get cut off. Ag producers don't have enough water and they have to stop their irrigation. That hits the bottom line, that hits their livelihoods. When there's not enough water, everybody takes an impact. But when we have accurate water supply forecasting, we can make better decisions to be able to plan for those cutoffs, to be able to plan for having a limited water supply. so that reservoir operators can figure out how they're going to manage their reservoir throughout the year, how much water they need to hold back or how much water they're going to release early in the season. And with more and more uncertainty, we've seen that our water supply forecasts don't always give us the full picture, but that we may need additional tools to help understand these missing relationships that we haven't taken into account in the past. So it's a tool in our toolbox. Soil moisture is one of those tools, or maybe a variable in our algebra equation for solving that really complex problem that varies across every region within Western Colorado and beyond. And there's still more questions than answers. We still need to look into all of these relationships so that we can understand them, but we need to understand these relationships so that we can conclude them in our models to get a more accurate forecast, to be able to address the uncertainties that we're seeing in the Western United States and respond to climate change and drought and be able to be sustainable for the future. And that's all I have.
Thank you so much for that. Do we have any questions? I'm gonna go to someone else for Peter. Sorry.
Great presentation, thank you. Real quick question regarding goodness. On a previous year that you got about 60% of the flow estimated, and I was wondering if you use something like that Iron system, if you input since you had that you're already covered at that time. And your goal, have you tried using like an average field capacity across those 10 stations leading into the melt season or something to help predict like 100% loss you may see, and if that relates at all?
Yeah, you know, that's a better question, honestly, for Elise. I wasn't the one overseeing this project at all, but I'd welcome your input. That's a great question.
Yeah, so part of the project that Rebecca mentioned was looking to try and see if there was a clear signal between soil moisture and stream flow. So looking to look at that here in other years. There we go. What we saw was that one is a challenge that in Colorado that 10 or 15 basically is the thing. And so what we'll do is do the data analysis because we didn't have enough variability at some of the stations. Not all of the stations have that on the records of the stations that we were. And so really what this is but long story short,
this is a need for the community, that there's data out there and we're getting to a really exciting point as the soil moisture community as a whole, where there's starting to be more data sources, but there isn't a great pathway yet to get that in situ data into something that someone like Rebecca or someone like a water manager can look at it and say, oh, my soil moisture number this year is X, so I'm gonna see Y. So I'd love to hear from Rebecca if you want to say anything about what type of data you do look at.
Yeah, I mean, we're not, my organization isn't doing the forecasting. We're really relying on those forecasts from other federal agencies like NOAA and the Colorado River Basin Forecast Center to provide data to our water users. And I know it's very difficult, for the Colorado River Basin Forecast Center to include in situ data and these models that are really, really large. They're looking at sometimes the entire upper Colorado River Basin. And so using modeled soil moisture is a maybe more effective tool for those larger scale models. But what I think can be a really effective method is, using those models in a way that's also incorporating what we understand about different watersheds. And I think trying to develop these long-term records in the Roaring Fork watershed and the Yampa River Basin watershed can give us an idea of, okay, how does soil moisture play into this conversation? And how can we alter our models, even if it's with modeled soil moisture, to be able to get that model to more accurately define our water supply? And I think that's the missing component that we need to include in these models.
All right, yeah, that was really interesting. Glad I wanted to catch up with you on there. I'd never seen the slide with all the water in Western Colorado, so that was really cool. One thing that I wondered about, I know your equation was intentionally simplistic because it was trying to communicate a point. One communication issue that I went into in Colorado is that if you people expect, you have 80% of normal sweet, you're gonna get 80% of normal runoff, and that's not the case. They're not one-to-one. And so I wonder if you run into that communication issue too, and like, if you thought about maybe including like a multiplying factor in that equation when you show it, just since that is such a point that a lot of people miss, is that if you get 80% of normal soil or normal sweet and 60% of normal runoff, that might be exactly what you expect.
Yeah, thanks, Peter. And I did make that a very simplistic equation because my supervisor boss, who's a lawyer, doesn't like it when we put in too many graphs. So, trying to simplify it. Yeah, that's a really good component. And I think it's something that's difficult to explain to the public, but it's also something where when we're looking at a drop between, a 90% snowpack, and then we're looking at a 30% stream flow runoff. In addition to that year, I should mention that there was a huge drop between the April 1 forecast and the May 1 forecast. So it's not just looking at that, kind of going from the snowpack to the stream flow. It's also, it's really when we're seeing that drop in forecast, that's where is the really big, kind of concern that we're seeing. It's just when that amount of water that they're forecasting drops so significantly.
Yeah, well, my question was more on the post-project side, where after the station is installed, how does your office go about explaining to the public, or say the water users or anything like that, why those stations were installed there, outside of this scientific room? I think moving on to why you install a station somewhere to where they're going to use the data if they were to. How do your office go about explaining that process to the public?
Yeah, that's a really good question. We're kind of a strange organization in that we're not really the ones doing the projects on the ground most of the time. We're really facilitators of those projects. And so we do serve as a mouthpiece for explaining projects that are happening within our basin and why and how that's supporting our constituents. And one of the ways that we do that is by going to these state of the river events, or planning these state of the river events where we go out to the public and have meetings within each basin and talking about the projects that we have, that we're funding and that we're supporting. And so we have had representatives from that Y Basin network, for example, who do presentations for the public at our events to talk about why they're doing this data and why it's important and how it can help them. And I think we have a pretty informed water user base actually in Western Slope, Colorado. And most of them kind of get it, water users, ag producers. They're on the ground seeing these impacts. They're looking at the amount of snow that's available, and then the water forecasts that come out, and then seeing that water just disappear by the time we get to late summer. So I think it's easier when you're living the impacts to be able to explain why you're doing projects. And that's been a really helpful tool.
If you have questions specifically about the Y Basin installs, Jacob, raise your hand.
Yeah, I forgot to mention, he's leading one of the field trips tomorrow, so you should pepper him with all of your questions.
How much conversation is there in your community about the effects of wildfire and water forecasting and either predicting the wildfire seasons as it approaches, or discussions post the wildfire and season, what that means for the future?
Yeah, I think it really varies on the basin. There's different areas within our district that have had a lot more fire impacts than others. The Steamboat region, I would say, is really, really aware of fire risk just because they're in a high risk area. Most of their community is pretty much in the wilderness urban interface. And so that's a really big concern and something that a lot of groups are working on. Other areas are not using it as much. But we've also seen a lot of wildfire impacts. For example, in the area where our office is, we had the Grizzly Creek fire, which had really devastating impacts, more so to the water quality, I think, than the quantity. But it really kind of instigated a lot of conversations in terms of setting up a redundant water supply for the cities in that area. But that was a little bit more based on the water quality impact. So it's certainly a conversation, but I think the topic depends on the area.
We have time for one last question. We start getting the slides of our next speaker up. Anyone else with final question on hands? Got them all. We did. Okay.
Thank you very much.